All right, the third speaker in this, or fourth actually in this group, is Karen Worcester from Central Coast Regional Water Quality Control Board. She's a senior environmental scientist and has worked there on swamp and ambient monitoring programs for many years. And that region in particular has 10 plus years of watershed-based, outcome-based performance management. They're well ahead of many of us in terms of this. So she's going to talk a little bit about the CCAMP program. Thanks.
Thanks, Greg. Is it on? Can you hear me? Yeah. Hi, good afternoon. Thanks for having me. I am going to talk about some work we've done in our Central Coast region. You've heard about a lot of different kinds of data today: toxicity data, pesticides, water quality, biology, habitat. There's a lot out there. And one of the things we've tried to do in our region is to pull it together in a tool that makes it accessible to our staff, makes it easier to use and interpret, puts it on desktops. And I think we'd all like that. And I really would like to see someday, you know, this type of thing, maybe not this tool, but available for the entire state. So I'm going to talk to you a bit about that. I want to, before I start, thank and acknowledge Dave Paradis back there, who's done all the software development. He's also my reluctant data wrangler. And that is something to note. There's a lot of data wrangling involved in any effort like this, and it's probably taken 90% of our time. So it's an important issue I think we're all trying to address in a better way, and I just can't express more the importance of that notion, meaning keeping your data in order. Okay, do I have an advancer here? Is that? Okay, we could go deeply into acronym land, talking about the various types of data repositories, portals, and tools that are out there. And there are a lot, and they're becoming more available every day. And I just want to briefly acknowledge this, that there's so many ways you can get access to information. Primarily in our agency for surface water, the California Environmental Data Exchange Network. There's also national portals, for example, the one presented by the National Water Quality Monitoring Council, their water quality portal. It's primarily about storing and making access to data. And then there are other systems that store and also provide a higher degree of analytical tools. For example, our GeoTracker Gamma program is a good example, as is EcoAtlas, which is a SFEI developed as a way to store and provide access to wetland and riparian data as well as other data types. We have our own My Water Quality data portal, which provides access to I'd say it's a question-driven system that provides access to assessments in a variety of formats, maps, graphs, and text. And this is a system that I really would love to see our own system someday associated with. I'm going to describe that now, starting with our Healthy Watersheds report card. And this tool, the reason I think this is sort of unique is the user doesn't have to know everything in order to learn something quickly about an area they're interested in. A lot of tools you need to know, well, nitrate is the interesting analyte in the system, so I should pull down that data and look at these particular sites. It can require a lot of user upfront information to extract information quickly. So this is a drill down where you start by assessing it for health, and then you can drill in more deeply for information. So it was initiated by our own region quite a few years ago. In 2007, I think we started trying to address our vision of healthy watersheds. So we set up several goals that primarily around healthy aquatic habitat, proper land management, and clean groundwater, with the idea we wanted to know what % was healthy and where it wasn't healthy, where was it improving. So that was sort of what initiated our project. So the way our report card works is you can look at either aquatic life, I'm going to go through this pretty quickly, or human health grades. The upper bars show you the % of the region in the various conditions in sort of a report card analogy of health. And then you can select a hydrologic unit of interest. In this case, I'm selecting the Pajaro River. I don't think you all can see it in the back. And drill in. The list on the bottom shows you the various water bodies in that hydrologic unit and how each of them have scored according to our monitoring. So I'm going to look at Yagas Creek, which scored a D, and we say, why is it scoring a D? That's not a good score. We drill in further, and it gives us a site list, and you can see which of the sites in that water body, how they scored. So I'm going to go look at one of the ones that's in poor quality, which is the one I just picked. Drill in one more level of detail, and we get to the actual report card. And I don't know if I didn't point it out, but the map is zooming in as you go, which shows a series of indices, conventional analytes, biostimulation, biology, toxicity, metals, organic chemicals, and it scores each of those. And you can see up in the map, it's zoomed in on the August Creek watershed area, and the sites are shown in color, as is the reach under the sites shown in color, and I'll talk more about that in a bit. And there's also a spatial assessment underlying that. Okay, if I want to zoom in on the conventional analytes in more detail, it brings up the list of parameters that we measured in conventional analytes. And it shows you, for example, nitrate is in pretty poor condition, ranging up to 22 milligrams per liter at that site. So needless to say, it scored an F and is contributing to the poor quality in that location. So it really gives you a quick way to look in and say, what's causing the problem? You know, what kinds of problems do we have in this location? We have another tool that takes you another level of detail in. This is our data navigator. This has been up online for a number of years now. And it provides you at the sites and at Watershed various scales of detail. You can look at the actual data. You can download the data. You can look at summary charts of the various analytes measured, and it also provides statistical tools. For example, this is a trend analysis. We do both a linear trend and a change point analysis. So it gives you access to the data all the way from the highest level of, you know, a generalized report card to high level of detail. So our scoring approach is based on an approach used in Canada that's well respected. It's not identical, but it's similar. And it does require a threshold. So some of our analytes are not scored, color scored, because we don't have a threshold that's appropriate for use. It includes two components, so it's not just based on how many times does it exceed, it's also based on how much, by how much does it exceed that threshold. And as I mentioned, it follows the basic, you could call this the stoplight paradigm, which definitely gets the attention of the user, for better or for worse. And we have identified what we call our A+ score, which is where all of the analytes taken in total score very well. So it's like a blue line stream, A+ stream. So this is a typical map in our region. This is a typical pattern for our region. Those dark red areas are where a lot of our irrigated lands are. The bright green areas are where we have some of our more protected coastline, Big Sur Coast, for instance. This happens to be nitrate, but we see this type of pattern in many of our parameters. So all of our data is scored at the site level by analyte, and then we take that and combine it into an index. So I mentioned before, we have a number of indices that pull data from multiple sources. So we're not just taking data from CDIN, for instance, into these indexes. And I wanted to mention the habitat one specifically because it's one we've been working on recently in the last month or two. We're hoping to use some of the work Andy's been doing. We're also using CRAM and a relatively new riparian assessment method being piloted in the Central Coast called RIPRAM. That's really sort of a linear riparian assessment. You can talk to Kevin right here up front if you want to learn more about that. Hey, Kevin. So the next thing that we do after we score at the site level is we're rolling that data into a spatial assessment of whole watersheds. And we start by basically overlaying our measured data on top of a modeled assessment of health for a region. And then we allow those the measured data to modify the scoring of the model. So presuming that the measured data reflects it more accurately. So we let the site scores basically change the, attribute the site score to the reach upstream of it. So it travels upstream until it hits a major land use boundary, and then it cuts off, and then the model, underlying model, continues to score. So this is from California's Healthy Watersheds assessment, and this is the many data layers available online that they're in GIS format that you can use. Hundreds, I think, quite a few data layers. And we used some of the data layers from this assessment as our modeled layer. And this shows the California Stream Health Index. That's one of the 3 sort of combined indices they came up with. This picture shows that same data converted into our own coloring paradigm. And these are our own index scores on top of that. You can see the same basic pattern, which really shouldn't be a surprise because some of our bad areas are so bad, and good areas and good quality, and they have few stressors. So, but there's also plenty of locations where the colors are not matching, and you can see that more clearly here. We're just showing the 2. Let's see, our index is on the x-axis. So we're presuming that sort of shows you how well the model is describing the actual condition. There's some scatter there. So what I described before, where we're using our own data, so this is going back to Yagas Creek. The colors on the background are the model. That comes straight out of the states model, which actually worked pretty well for our region. But you can see, for example, in this case, part of that valley floor of Yagas Creek scored better with our actual data than the model shows. So we use our actual data to modify the assessment in those areas. So I think this tool, it's a great example of a really versatile approach to assessing data and getting access to the details that can help you make decisions, because it helps you understand where things have a problem and why, and in a relatively painless way. So I think it's a really, 3 minutes, thank you, perfect. But I wanted to, in the meantime, since this is only in Region 3 at this point in time, I wanted to also mention there's another really interesting tool that's out there right now that we're going to be, I hope, employing as we move into some of our other goals. For example, one's more related to land management. This is called EPA's Recovery Potential Scoring Spreadsheet. It's a little Excel-based tool that you can download. It has hundreds of indicators loaded into it, and you can, basically, you create 3 indices by selecting the indicators you want to use, and they're actually going to upgrade it to, like, I don't know, over 500 indicators. So what they've done is they've provided scoring for each HUC 12 little watershed area. So this is our region. The little gray outlined areas are HUC 12. So they're relatively small little watersheds. So each one has a score associated for each of these data layers. So for example, and then you create 3 indices. The first one here is ecological indicators. The second one is stressors, and the third is social. So ecological indicators would be things like the percent of natural cover, the percent of forested land, things like that. The second one, the stressors, the things that they give you are things like percent high intensity developed land, percent of cropland, that kind of thing. And then the third one, social indicators, are basically our ability to affect change, whether for better or for worse. So it could be, is there a TMDL in place? Is there a permit in place? Are there protected lands? And the really neat thing about it is you can add your own layers. So you can customize it for your own purposes. So we can take some of the data we've created at the HUC 12 scale and load it into here, and it will roll up into these indicators. So it creates the map I'm showing you. The map is actually embedded in the Excel tool. It gives you a little color gradient. And it also creates this little bubble plot. So a bubble plot is basically a three-dimensional plot in 2 dimensions. So in this case, the stressors are on the x-axis, ecological index on the y-axis, and then the ability to affect change, the social index, is the size of the bubble. So you can see, for example, the lower right quadrant are things that are heavily stressed and in poor condition, as you might expect. The things in the upper right quadrant, there's almost nothing there, because usually when things are heavily stressed, they aren't in good condition, so nothing shows up there. On the upper left is things that are in good condition and are not stressed. And then things that are in good condition and have low stress. Or I'm sorry, that are in poor condition and have low stress. So it basically helps you decide where it's going to be valuable to place your effort. So if you have a high capacity to affect change through permitting tools, through regulatory efforts, through access, just through access, those are going to be the things that might show up in the lower left box. You may also have things you can change in the high quality areas through, say, protective measures like it's in a preserve, for example. That would be a protective measure where you expect high quality. And there may be other places where the ecological value is not there, so it's really not worth putting your efforts. So it's a really neat tool that is very easy to use. I learned it in a couple of days, and it was really, I thought, a good thing to explore. So I just wanted to bring that up, and then I also wanted to mention, it's my last slide, that this project for us just brought home, first of all, this issue of data wrangling. Again, so important that as we build tools, as we build data systems, we keep applicability with other systems in mind, because there's so many things being developed out there, and the easier it is to interface between these systems, we'll just all be so much farther ahead. And that also gets back to the idea of standardizing formats and vocabulary. It can't be overemphasized. And then I really believe in focusing on high priority applications that will really support our own decision making. So that's pretty much what I have to say today. If there's any questions.
Hi, Karen. The EPA tool, have you tried to, or can you import the CSCI scores that were predicted from the healthy watersheds into that?
I think you can, because it's a HUC 12. Yeah, Dave wants to answer. Go ahead. Yeah.
Okay, thank you.
There you go. It's all it's because it's an Excel. It's not a GIS base, so it's just a table with the HUC 12 number. So anything that's stored that way, you can just put right in it. So it's pretty straightforward. It's a cool tool.